Hi, girls, this is our video on prime numbers, 3D. Now, a prime number, which you probably already know from year 6, is a positive whole number that has only two factors, 1 and itself. So there's other things, though, here we have to know. First of all, 0 and 1 are neither prime nor composite. Composite numbers are all the other numbers besides the primes. So let's look here. They've already told us 1 is no good. So my claim is that 2 is the first prime. Now, if 2 is in, or divides into evenly another number, then that number would not be prime because it would have 2 as one of its factors, not just one of itself. So I want you to pause and I want you to cross out all the even numbers because those are the numbers that 2 goes into. Just finishing off. Okay, I've crossed out all of the even numbers. I should have mentioned that what I'm really doing is called the Sieve of Aristophanes. So this guy was a Greek guy, and he kind of invented this way of showing prime numbers. And a sieve, or a sieve, as we say in the United States, is something that holds all the good stuff. So when you put your pasta into a colander, it shakes out all the water and leaves you with the pasta. Or when you pan for gold, there's a sieve that you put in the water, and all the dirt and debris and water falls through, and just the gold stays in the pan. So this is a sieve. This is how it works. The next prime number is 3. Now I need to cross out all the multiples of 3. So you might be really good at doing that. You might be able to go 3 times 3 is 6, it's gone. 3 times 2 is 6, 3 times 3 is 9, so it's gone. 3 times 4 is 12, it's already gone. 3 times 5 is 15. Okay, some people aren't good at their times though, so they can just count. They can go 1, 2, 3, cross it out. 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 Now, I'm going to keep doing that, and I'm going to pause, and I want you to count by 3s and cross out 2. Okay, I've crossed out all the multiples of 3. I want you to quickly go through and make sure you have the same things crossed out that I do before you move on. So pause the screen and make sure you have it. 5 is the next one. The 5s are easy. All the things that end in 5 and end in 0, 5 can go into. So I'm crossing all of those out. 7's a little bit harder, and I might want to count by 7. 1, 2, 3, 4, 5, 6, 7. It's already crossed out. 1, 2, 3, 4, 5, 6, 7. It's already crossed out. And I'm going to keep counting by 7 and cross out all the multiples of 7. I think the first one I found was 77. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 91. 1, 2, 3, 4, 5, 6, 7. Okay, I've crossed out all the multiples of 7. Looks like 11 is the next prime, and the multiples of 11 are just straight across this, and they're all gone already. So I'm going to do 13. 13 and 13 is 26. It's already gone. And then if I add 13 to 26, I get 39. It's already gone. And if I add 13 to that, I get 52. Sorry, I'm doing the 13s. I got interrupted, but I'm back again. 13 is 26. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 39 is crossed out. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13. Gone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Gone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Gone. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13. Gone. So 13, there, that's great. 17 is my next one. Then I'm going to count by 17s and make sure there's no more multiples of 17. There weren't any. So 17's alone, and then 19. And I think, girls, that all these leftover numbers are what stayed in our sieve. I think these are the prime numbers. So that's really great that we have a nice big fat list of prime numbers that are sitting there. And we know they're prime because we've counted and checked all the things that might go into them. I think we're up to here. I'd like you to go on the internet, though, and look up the list of the first prime numbers up to 100 and see if we got it right, and maybe write your list out here. That would be great. Okay, the next thing we need to talk about is state whether each of these is prime or composite. This is certainly composite because it's crossed out. This is certainly composite because it's crossed out. This is prime, this is prime, this is composite. So we know from our chart up there. Find the prime numbers that are factors of 30. So I want to say, okay, 1 is not a prime number, but I know 2 goes into 30, 15 times. 15 is not prime, so I won't write that. I know 3 goes into 30. I know 5 goes into 30. And I think that's it. So those prime factors, 3, 5, and 7, go into 30, and none of the other ones do. Okay, there's your work down at the bottom.